This is from 2009. Question number 3. The limit of the expression x tending to 0 sine of x squared pi by 2 upon sine of pi x by 2 the whole squared. Okay, let me write it here. It's a bit small font. Limit x tends to 0. There are two functions here. The numerator is sine of pi x squared by 2. So pi by 2 is there, and then we are squaring x only. And in the denominator it is sine squared actually of pi x by 2. Okay, sine squared pi x by 2. Okay, that is what we have now. And well, in almost every case it will be in 0 by 0 form, and even here you see it is already in the 0 by 0 form, right? Sine 0 0 sine 0 0. Okay, so can we apply the L'Hospital's rule there? Can we do it? Yes, we can apply L'Hospital's rule here. Okay, let's do it. Okay, first go for the numerator. It is cos of pi x squared pi 2 into chain rule, derivative of inner function pi by 2 as it is into 2x. Okay, come to the denominator. In the denominator we have got sine squared, isn't it? Sine squared, so it will be 2 sine pi x by 2. Okay, 2 sine pi x by 2 into cos pi x by 2, because first we have taken the derivative of squared. So now the inner function is sine. Its derivative is cos. And then this should be multiplied by derivative of pi x by 2, which is pi by 2. Okay. Now pi by 2 goes. 2 they also go. And I am now recommending you not to apply the rule again. Okay, not to apply the rule again, but take out the terms which do not give you 0. Pi x squared by 2 is one of them. The other one is pi x by 2. Oh wait, is it giving a 0? Oh, okay, sorry. It is giving, oh no, sorry, it's not. Sorry, I got confused because of pi by 2, but x is tending to 0. Okay, so that won't be a problem. Okay. Now what is left? In the numerator x is remaining, and in the denominator sine of pi x by 2 is remaining. Okay, I think I'm not missing anything here. Cos of pi x squared by 2 is there, cos pi x by 2 covered, x covered, sine pi x by 2. Okay, good. Now, do you agree that the first term here will be 1? Cos of 0, 1, cos of 0, 1. Yes, that is going to be 1. And look now, for the second one, I will write 1 in the numerator. Okay, and I will send that x in the denominator. So it will go in its denominator, and because this has pi x by 2 there, okay, let me divide this by pi by 2, okay, and then let me multiply this by pi by 2. Okay, so this limit becomes 1, this limit becomes 1, okay, and that is pi by 2 in the denominator. So eventually it will come in the numerator and become 2 by pi. Okay, 2 by pi, that is option C. That is option C. And if you are not convinced how we did that, if you are not convinced, fine. So we can apply the L'Hospital's rule right here also. Okay. So see, this is our step. Then here we have made that adjustment, or what can we do? We can say, let us differentiate that again. Derivative of x is 1. Derivative of sine is cos. And then derivative of inner function. So that eventually again will give you 2 by pi. Got it? 2 by pi? Yes. So the answer in decimal form should be somewhere close to 0.6. Right? Somewhere close to 0.6. So you can do it on calculator, but let's do it on Desmos this time, because that square part is a bit difficult to enter in my calculator. ठीक है. So what is the function? Sine squared in the denominator. Okay. Sine squared pi x pi 2 in the denominator, and in the numerator we have got sine of pi x squared by 2. Okay, so this is the graph. It's a pretty decent looking curve, and okay, fine. Look, we are only interested near 0. See, at 0 it should show as undefined. See, look, at 0 it is showing undefined. Okay, and if I draw a horizontal line y equal to 2 by pi, that appears to be a tangent to that curve, but it is not, because the function is not defined there, but it matches. It's 2 by pi. Okay? Okay, by looking at this graph, can you tell me whether our function is odd or even? Yes? By looking at this graph, can you tell me whether this function is odd? It is an even function. Look here. For sine squared, you are convinced that it will be an even function, because, well, even odd into odd is even. But take a look at the function in the numerator. Sine of pi x squared by 2. Sine is odd, but what about x squared? It is even. That would make it even function. So even if we just plot the numerator's graph, okay, even if we just plot the numerator's graph, that would still be symmetric about y-axis. Albeit a non-periodic function, that is still even. Okay, that's the way. Okay, cool.